percentage, we eliminate by providing inputs to my bit stable element. And that circuit which provides input to my bit stable element is known as a SR latch. Okay. So let's see what is my SR latch. My SR latch looks like this. It has 4 ANDs. Okay. 4 NANDs rather. So this is my one NAND. This is my another set of NANDs. Okay. Now let's see what this is. The first half, this half is similar to your bit stable element. So you have an output, okay. You give this output to this guy, you give this output to this guy, okay. And over here you provide the output as input to this, and you provide the output as input to this, okay. And over here you have your 2 inputs. You have a S input over here, you have a R input over here, okay. This is called as set input, this is called as reset input, okay. And a special thing over here is you have a clock, okay. Let's call this a clock. What is a clock? Clock is just a synchronized pulse. So your clock looks something like this. Okay, it is a pulse with a fixed duration. So this is your clock. Okay, something like this. It has a fixed duration which is repeated. Okay, this is your clock which you input from here. SR latch works only when your clock is in a particular position. Either when your clock is on a high level or when your clock is in a low level, then only a SR latch works. So I am going to write over here, SR latch is level triggered, okay. So a level triggered can be either positive level triggered or negative level triggered. So let's just write this as positive. Let's use a different color. I'm going to use red, okay. Positive. When you have a positive level triggered latch, then it means your latch is going to work when your clock is at a high signal, okay, at a high level. And you have a negative level triggered latch, which means I'm going to write negative. Okay, this means your circuit or your latch works when your clock is at a low level. Okay, it is either going to work in a high level or low level of the clock signal. Okay, so this is your SR latch. You have your Q over here, okay, and you have your Q bar over here. So I am assuming that this SR latch is positive level triggered. So let's see how this circuit works on the basis of different inputs. So I am just going to write over here, assuming positive level triggered. Okay, so let's suppose what happens when you have, let's say S is equal to 0, okay, R is equal to 0, and your Q is equal to 0. Okay, now let's see what happens. So over here I have S 0, okay, R 0, and Q is 0. Okay, now S is 0, and if my clock is low, okay, if my clock is this, then this circuit is disabled. Okay, look what happens. If this is 0, this is 0, then 0.0 bar is, this is 1, and okay, here you have a 0, okay, because this guy is Q is 0, so here you have a 0. From here again 0.0 you get a 1, okay, 1.0 the whole bar is 1. Okay, so what you get over here, you get a 1 over here, okay, and 1.1 the whole bar is 0. So you get what you have. So in a way your circuit is in a inactive state when your clock is low. Okay, I say my circuit triggers or changes state only when my clock is at a positive level. Okay, so I have seen why my circuit does not change state when it is at a low clock level. Okay, now let's see what happens when my circuit is at a high clock level. This is 1, this is 1. Okay, 0.1 the whole bar is what? Is 1. Okay, because 0.1 is 0 and bar of 0 is 1. Similarly 0.1 the whole bar is 1 over here. Okay, you have 0 coming in from your Q, so 0.1 the whole bar is what? Is 1. Okay, so you are getting right Q and Q bar, because Q bar should be complement of Q and Q is 0, so Q bar should be 1 and I am getting 1. Now let's see what is happening over here. This one is here and 1.1 the whole bar is 0. So here also your input, or sorry, your output state is same. So what I can say is, when you have this, your Q next, which is your next state, is 0. Okay, but I do not call that your circuit is inactive. Why? I am going to show you just now. Now let's take another scenario when my Q is equal to 1. Okay, when my Q is equal to 1 and SR is equal to 0, then let's see what is happening. S is equal to 0, R is equal to 0, and Q is equal to 1. Okay, and I'm talking only about positive clock trigger. Okay, positive clock level. Okay, you have 0.1 the whole bar. What is this? 0.1 is 0. The whole bar is what? This is 1. Okay, similarly you have 0.1 the whole bar, which is again 1. Okay, now you are getting 1 from here, so this is 1.1 and the whole bar. 1.1 the whole bar is 0 and you are getting 0 over here. Okay, and 1.0 the whole bar is 1. So I get my Q next is equal to 1. But just understand, I still do not call my circuit as inactive. Okay, this we are going to see in this scenario when S is equal to 0 and your R is equal to 1. Okay, then let's see what is happening. First I am going to see what happens when your Q is equal to 1. Okay, because my Q is already 1 over here. Okay, we are going to see what is happening. My R is 1 now. My R is 1. Okay, my 1.1, the bar is 0. 0.1, the whole bar is 1. 1 I am getting from here. 0.1, the whole bar is 1 over here. Okay, and 1 I get from here, and 1.1, the whole bar is 0. So as you can see, your value of Q, which is your state, changes and it is complementary. This is 0, this is 1. So my circuit has been triggered or has made a transition. So I call Q next equal to 0. Okay, we are also going to see what happens when S is equal to 0, R is equal to 1 and Q is equal to 0. Okay, let's see that as well. Q is equal to 0 as it is. We are going to take off everything else. This also is going to remain same because I have not changed my inputs. Okay, so this is 0, this is 0, 0.0 is 0 and invert of that is 1. I get 1 over here, 1.1 is 1 and invert of that is 0. So my circuit remains in the same state. My Q next is equal to 0. So you can say that whenever your R is 1, okay, your Q next remains in 0. Okay, your next state becomes 0. And you can say whenever your S and R are both 0, then your Q next is equal to your previous Q. Okay, you can see this is same and this is same. Okay, so here I am going to write your Qn plus 1 is equal to Qn. Okay, this is your Qn, this is your Qn plus 1. Okay, your next Q and your previous Q. Here I can say whatever be the Q value, your Qn plus 1 is equal to 0. Okay, now let's take this out. Whoops. Yeah. Now we are going to look at another scenario when your S is equal to 1, your R is equal to 0 and your Q is equal to 0. Let's see what is happening over here. What has changed? S has become 1, R has become 0. Okay, everything else I am going to take out. Your Q is still 0. Okay, look, I have written my Q as 0 over here. We are looking at this scenario. So 1.1 is 1 and bar of 1 is 0. Similarly 0.1 is 0 and bar of 0 is 1. Okay, now I have a 0 over here. Okay, and whatever be the input, 0.x bar is going to be what? This is going to be 0. Okay, so 0.x bar is going to be 1. So what happens is this q becomes 1, okay, and this 1 is over here, and 1 dot 1, the whole bar is 0. So my q next is equal to 1, okay. Now we are going to see what happens when s is equal to 1, r is equal to 0, and q is equal to 1, okay. So where am I? I am here. My q is equal to 1. This remains as it is, right? Because I have not changed the inputs. So my q is equal to 1. Okay. Since my q is equal to 1, again, since this is 0, q is anyways going to be equal to 1. Or if you want it in other terms, this is 1, you can get a 1 over here. 1 dot 1 is 0, and you get 0 from here. 0 dot 1 is 0, the whole bar is 1. So it is as it is. So you are having q next equal to 1. So I can say over here, your qn plus 1 is going to be 1. Okay, this is your condition when s is equal to 1 and r is equal to 0, irrespective of your q value, irrespective of your previous state, your next state is going to be 1. Now I am going to take a final scenario where my s is equal to 1 and r is equal to 1. Okay, let's suppose q is equal to 0. Where am I? I am here. I'm going to take this off, take this off, take this off as well. This is not required. This is not required. This is not required. Yeah. I have this also 1. Okay. Now 1 dot 1 is 0. 1 dot 1 is 0. Okay. 1 dot 1 bar I am talking about. Okay. So I am assuming this is 0, okay. So this 0 comes here. 0 dot 0, the whole bar is 1. This 1 goes here. 0 dot 1 is 0 and the whole bar is 1. I get a 1 over here. Now this is a problematic situation because I am assuming q and q bar are complement of each other, but in this case I am getting q equal to q bar. Okay, therefore I say this scenario is indeterminate. Okay, so I am going to say that when s is equal to 1, r is equal to 1 and q is equal to 0, this is a indeterminate situation. Okay, because my q is becoming equal to q bar and my observation is that q should be complement of q bar. So I call this as indeterminate situation and I should not have this as input. Okay, the same thing happens when s is equal to 1, r is equal to 1 and your q is equal to 1. So I can create my truth table like this. I have my S, I have my R, okay, and I am going to say I have my Qn plus 1, which is my next state, okay. So as you can see from here, when s is equal to 0, r is equal to 0, next q is same as the previous q. So I am going to write 0, 0, qn plus 1 is qn. Okay, similarly, when q is equal to 1 or q is equal to 0 and s is equal to 0 and r is equal to 1, I get q next is 0. Okay, so I am going to say When S is 0, R is 1, your Q next is 0. And when S is 1, your R is 0, your Qn plus 1 is 1, or your next state is 1. And if you have 1 1, this is your indeterminate condition. Okay, I'm going to put a question mark. This is something that you should not have. Okay, so this is your truth table, or in other words, I call such a truth table where I have input variables and my next state a characteristic table. Okay, characteristic table. It is a combination of input variable combinations. Okay, I'm not able to write it. Input variable combinations and your next state. And next state. This is called as a characteristic table. Okay.